In this video, we're going to look at several different ways to use a while loop. The programming language we're going to use is Python, but these same techniques apply to just about any procedural language since most of them have while loops built in. On the right side of the screen, we have our Python program editor. I've already put some header comments into the program. The comments will help me remember what the program does the next time I look at the source code. You'll also see a print instruction which tells the user what's going on when the program runs. The first kind of loop we'll do is a simple loop that counts from some number to some other number. Many languages have a for loop to do this, but Python's for loop is different, so we'll use a while loop to do our counting. Here we ask the user how high to count. We convert their input into an integer and put it into the variable called max. While loops typically have 3 or 4 parts depending on how you count: initialization, test, increment, and the body. The body of the loop is the part that gets repeated, and often this includes the increment step. So here first we initialize a variable, which is the loop counter. Here I'm using the variable I. The while loop is by nature a top-tested loop, meaning a test is done at the top of the loop to decide if the body of the loop will be executed. If the expression is initially false, the body of the loop will never execute. This indented section of the code is the body of the loop. This is where the work is done. In this example, we're just printing out the value of a variable, and then we'll do the increment step, which will get us closer to completing the loop. Your programs will do more interesting things in the body of the loop than we do here. Here's the increment step. We're adding 1 to the variable I to get us closer to the max value. In Python, the body of the loop is indented. This line, which is no longer indented, signals Python that is no longer part of the body of the loop. So the while and the next unindented line are the bounds of the body of the loop. Let's run the code to see what happens. So the program starts and it asks us how high to count, and I'll just put in a number, for example, 6. The loop runs while our counter is less than or equal to 6, printing out the value of the counter and adding 1. After it prints 6, 1 is added to the loop counter, making it 7. So this 7 is no longer less than or equal to 6, and so the while instruction knows not to go back through the body of the loop. This example of the counting loop is useful if we want to process all the numbers between the beginning number and the ending number. But what if we don't, ahead of time, know how many times we want to go through the loop? We'll need some kind of test inside the body of the loop to decide if we want the loop to keep looping. But the while loop is a top-tested loop, so sometimes we end up with code that asks for input at the outset and then asks for input again at the bottom of the loop, typically something like, "Do you want to try again?" Here's an example. It's another simple counting example, but this time we don't know at the outset how high to count. Here's the initialization step. Here's a question that asks the user if anything should be done at all, and we put the user's answer into this variable userin. Here's the body of the loop, print and increment, and another prompt to ask the user if we should keep going. We put the user's input into this variable called userin again. Then we test userin up at the top of the loop. Let's run the program to see what happens. Here's our initial question, whether or not we should do anything at all. The print instruction prints out the current value of the loop counter, and then the second prompt that's inside the loop asks us if we should keep going until we enter a value that is no longer y. So far, we've looked at 1 or 2 situations where a top-tested loop is appropriate, and one where we really wanted to do a bottom-tested loop. There's another kind of loop, the middle-tested loop, which lets us test wherever we want to in the loop, at the bottom, at the top or anywhere in between. It uses the Python break instruction, which is present in lots of procedural-based languages like C, C++, Python, etc. With a break instruction, we can do all three kinds of loops: top-tested, middle-tested, and bottom-tested. It's not very elegant when doing a top-tested loop, so I'd still recommend using while for the top-tested loops, but middle-tested loops are just what you need in lots of situations. We're going to make the while loop run continuously, then use the break instruction right here to get out when we want to. Here's some initialization code. We set some variable to some initial value. Maybe I is not the best variable to use in this situation, but we'll use I to stay consistent with earlier examples. Here's one way to make the loop run continuously. We just test to see if 1 is equal to 1. Well, it is, and it will continue to be. So the loop will run continuously, that is, until the break instruction gets us out of the loop. Here's an even better way to make the while loop run continuously. In Python, as in some other languages, any non-zero number is considered true. So we just can run while 1, which is the same as saying while true. Some languages even give us a constant value that is always true. For example, Python and C++ give us the constant true that we can test, and now our code looks like we want it to. We're going to run this while loop forever because true is true forever. So there are several different ways to code this expression that will always be true. With the number 1, with the constant true, or with the old-fashioned 1 is equal to 1. Next, our loop does some work. Here we're just printing out the value of I. Then we have to decide if we want to continue on with the code inside the loop. So in this case, we have a prompt, and we test the value to see if we should continue or if we should break out. In this case, we've asked the user to enter n to quit. We test the input to see if it's equal to n, and if so, we break out of the loop. But if we're not done, there's more work that needs to be done. We're going to convert the user's input into an integer, and then we're going to add that to this variable I. So we have some work to do before the test and some work to do after the test. So it's a middle tested loop. Let's run it to see what happens. Here we are already in the loop. We've printed out the value of our variable I. Here's our question in the middle of the loop, and we'll enter a number, say 3. It adds 3 to the loop, printing out the 4, and we're running through the input question again. But now we're tired of this, and so we're going to enter n to quit. And we don't bother adding any value to I again. In fact, we couldn't add the value n to I, which is why we got out of the loop with a break instruction first. Creating a middle tested loop using the break instruction often provides the simplest, most direct solution to a problem. Some programmers get stuck in a rut trying to make top-tested loops handle situations that would be better handled by a bottom-tested loop or a middle-tested loop. Another advantage of middle-tested loops is that you can use several break instructions to get out of the loop at different points, if you need to. I do encourage you, however, to put in comments explaining what you're doing so the next person to look at the code will easily understand what you're trying to do.